Hey guys, I want to take a second to go over some of the questions on our test review for the test tomorrow, since we don't have school today, and I think some of you are having questions about questions on the review. So I'm going to go over, I handpicked some of them, some that have been asked, and then I tried to pick at least one of each type of problem to go over. All right, the first problem that I want to go over is question number 3. So this is one where you're having to solve by factoring, and remember you do have to use the method that is asked in order to get full credit for the question. All right, so solving by factoring on this one, so I've got 12x squared plus 23x plus 10 equals 0. So I've got a trinomial. Notice the leading coefficient is not 1. So this is where you have to use the AC method. You're saying what are two numbers that add to 23 and multiply to AC, which is 12 times 10 or 120. So we're looking for those two numbers that add to 23 and multiply to 120. So you could list out your factors, 2 and 60, 3 and 40, and so on. I've done this one a few times with some of you who've asked, so I know it's 8 and 15. 8 plus 15 is 23, and 8 times 15 is 120. So now what you can do, some of us do this in other ways, but you can split the middle one up into 8x plus 15x. So that's 12x squared plus 8x plus 15x plus 10. So all I did was break that one up. And now you can factor by grouping, which hopefully we're pretty efficient at now. So group the first two, group the last two, factor out the GCF in each group. Now notice you've got the matching binomials there, so that's going to be one of your factors, 3x plus 2, factoring the 3x plus 2 out, and I'm left with 4x plus 5. Okay, so now you can set each factor equal to 0 and solve for x. So 3x equals negative 2, divide by 3, negative 2/3. So one of my solutions should be negative 2/3. And then the next one, 4x plus 5 equals 0, 4x equals negative 5, x equals negative 5 over 4. So I'm looking at negative 5 over 4 right here, so that's not it. It's going to be this bottom choice here. All right, I'm going to go to the next page. And now we're looking at one that says solve using the square root property. So that's just what it sounds like. You're going to end up taking the square root of both sides in order to solve. So we've got 2x squared equals 26. In order to use the square root property, first isolate the part that's being squared. The only thing that's being squared on this one is the x, right? Unless that's in parentheses, the square does not apply to the 2. It only applies to the x. So first divide by 2. And now I can take the square root of both sides. Don't forget the plus and minus. Anytime you take the square root, that number that you take the square root of, you get a plus or minus on. So x equals plus or minus the square root of 13. So that is your answer, positive 13 and negative 13. I know that negative is hard to see there. The font will be bigger on the test tomorrow. But that's it. Oops. See, not. Yeah, I'm not going to do that one, but I'm going to do the next one, which is just like it. Okay, determine the constant that should be added to both sides of the equation in order to complete the square. This should be a quick question on the test. You don't actually have to solve. You're just looking for the constant that you would add to both sides to complete the square. So what you have to know is that in order to get that constant to complete the square, you do b divided by 2 squared. That's how you get it. So here's b, 1/4. So you're going to do 1/4 divided by 2, which you can type in your calculator, squared. 1/4 divided by 2 is 1/8. You can think of it as 1/4 divided by 2 over 1. Remember, when you divide fractions, you flip the bottom one up. And so that would be 1/4 times 1/2, which is 1/8. And then we're squaring that. So square the top and the bottom. 1/64. Okay, so b divided by 2 squared is how you get the constant that you should add to both sides in order to complete the square. See, number 10. Okay, so actually solving this by completing the square. So I've got x squared plus 3x minus 9 equals 0. So first thing we want to do is add the 9 to the other side. If there were a coefficient in front of the x squared, you would want to divide that out first. We don't have that here. So we're going to do our b divided by 2 squared. That's 9/4, squaring the top and the bottom. So I add 9/4 to both sides. Okay, now I will factor this left-hand side. So two numbers that add to 3 and multiply to 9/4, it's actually always going to be x plus half of this number, so plus 3/2 squared, because we just created a perfect square trinomial. So I know it's going to factor into this binomial squared. That is the whole point of completing the square, so that you can factor it like this into something squared. Complete the square to make it a perfect square trinomial, so you can factor it into something squared. Now we need to add the 9 plus the 9/4. That should give us 45/4, which you can do in your calculator, or you can get a common denominator of 4 and add the numerators. Okay, now we can solve using square roots. So we will square root both sides. Don't forget the plus or minus. So x plus 3/2 equals. Now we want to take the square root of the top and the bottom. Square root of 45 over the square root of 4, which is 2. I can simplify the square root of 45. I can take a 9 out, it becomes a 3, and a 5 is stuck inside. Okay, and then last step, I just need to subtract the 3/2. Okay, I can't combine those because they're not like terms. One of them has square root of 5, the other one doesn't. So let's look at our options and see which one is correct. So the first option is not correct. It doesn't have the 2 in the denominator. The second option is not correct because it doesn't have the plus or minus. And the same thing with the third option. So the fourth option is correct. We've got our -3 plus or minus 3 square root of 5, and then they just put it all over 2, which is the same thing as having it broken up with both of them having denominators of 2. All right, so that's it. Okay, I'm going to do several on this page. Number 12. Solve the equation using the quadratic formula. So we've got x equals -b. Oh, well, first I need to rearrange this into standard form. So y squared minus 4y, just subtracting that over and adding the 9. Okay, so now that's standard form. So a is 1, b is -4, c is 9. So plugging that in, got -b, which is going to be +4, plus or minus the square root of -4 squared. Make sure you put that in parentheses. Minus 4ac, so minus 4 times 1 times 9. All over to a. Okay, now we simplify. Now you can put what's underneath the radical into the calculator. That's going to be negative 4 squared, which is 16, minus 4 times 9, which is 36, and I get negative 20. So underneath the radical, which is the discriminant, I've got negative 20. So the discriminant for this one is negative 20. So what type of solutions am I going to have? If my discriminant is negative, it is going to give me imaginary solutions, right? If I take that negative out of the radical, it becomes an I, which we're about to do. So that would be imaginary solutions. So that's like what we're dealing with on questions like 13 and 14, where you determine just what type of solutions you have based on the discriminant. So this one's going to have imaginary because your discriminant is negative. Okay, anyways, so let's simplify that radical. We can take the I out. We can also take a 4 out. It becomes a 2. So 2i square root, and a 5 is left inside, right? Because that breaks up into 4 times 5. You can take the square root of 4, it becomes a 2, and then the 5 stays inside. Okay, now we want to simplify. So you have to simplify, you have to reduce all 3 numbers that are outside of the radical. You can't just do 2 of them. Okay, so that's going to be 2 plus or minus. 2 divided by 2 is 1, so just I square root of 5. 2 plus or minus I square root of 5. There we go. And that's it. Okay, here just using the discriminant, these types of questions should also be very quick on the test. Okay, so this is just your b squared minus 4ac. So on this one, 5 squared minus 4 times 2, negative 2 times 5. Okay, and you can do that in your calculator. Minus 4 times negative 2 times 5. Okay, I get 65. Okay, now just picture that in the quadratic formula. The 65 is underneath the square root. So you're trying to determine what type of solutions you're going to have. Well, because of the plus or minus, you're going to have 2 solutions. So not 1. Because this is not a perfect square, it's going to be irrational. Your 2 solutions will be irrational. So that's actually the last one. And then you're not going to have imaginary solutions because there's no negative inside the radical. So they'll be real solutions. So if it's not a perfect square, it's always going to be 2 irrational. All right? Unless it's negative, then you get imaginary or complex. Okay, now let's try this one. So 4 squared minus 4ac. So 16 minus 4 times 5 times 5, 25. So that comes out to negative 84. All right, so since your discriminant is negative, in your quadratic formula, you're going to have a negative number underneath the radical. So that means I'm going to have imaginary solutions right here. Still have the plus or minus, so you will have 2, but they will be imaginary because I take that negative out and it becomes the I. All right, so that's how you determine the number and types of solutions. We're going to do number 16. Several people have asked me about this word problem. The formula represents the number of households in thousands. So n already accounts for 1,000. It is in terms of thousands. In a certain city that have a computer X years after 1990. Okay, so X is the number of years after 1990. According to the formula, in what year were there 111,000 households with computers in this city? So 111,000, which means N equals 111. It's already accommodated for the 1,000 in the N. Okay, so we're going to plug that in for N. And then you can use whatever method you want to solve this. As long as you set that up, you're good. You could use your calculator if you want. You can factor. If I subtract that over, I get 2x squared plus 6x. And then 3 minus 111 is negative 108. But look, these are all even. So I can take out a GCF. I can divide the whole equation by 2. So x squared plus 3x minus 54. So that's a lot easier. And I can actually factor that. So negative 54, looking for two numbers that add to 3 and multiply to negative 54. So let's see, I'm thinking 9 and 6. Yes, that will work. So the 6 is going to be negative. So x plus 9, x minus 6. And then setting each one equal to 0, solving for x gives me x equals negative 9 and x equals 6. Well, I can't have a negative number of years after 1990. So this is going to be x equals 6. And so since x is the years after 1990, you're going to add that to 1990, and it comes out to 1996. Okay. All right, question number 19. Okay, solving a radical equation. So you want to solve, you want to isolate the radical first. So subtract the 10 to the other side. Always isolate the radical before you do anything else. Okay, and then we want to square both sides to get rid of that radical. So squaring this, squaring that whole thing there gives me 2x equals. And now you need to FOIL that because remember that's x minus 4 times x minus 4. Okay, so that's x squared minus 8x plus 16 when you FOIL that. And then I'll move everything to one side, so I just have a quadratic equation that I can solve however I want. Minus 10x plus 16. Okay, so I like to factor. This is factorable, so two numbers that add to negative 10 and multiply to 16. So you've got 2 and 8. Oh, there it is. Make both of them negative. X minus 2, x minus 8. So they add to negative 10. So your two solutions are 2 and 8. But don't forget, on this type of problem, you need to check both of your solutions. So now that I have 2 and 8, I can either use the calculator. You can check by just plugging them back into the original equation, or you can plug it into y equals, look at the table, and see if both sides are equal. So I'm just going to write this out for us here. So plugging in the 2, I've got the square root of 2 times 2, which is 4, plus 10 equals x plus 6, so 2 plus 6. So let's see what happens. The square root of 2 is 2, so 2 plus 10 on this side equals 8. Is 2 plus 10 8? No. So that solution does not work. Let's try the other one. 2 times 8. So the square root of 16 plus 10 equals 8 plus 6. That's 4 plus 10 equals, let's see, 8 plus 6 is 14. Perfect. 4 plus 10 is 14. So 8 is the only solution. So remember, on radical equations, it's when you square both sides to solve, you have to, in some form or fashion, go back and check both of your solutions before you select your answer. Okay, so you get your two solutions and then you need to check them. Plug them back in or look at your calculator. All right, the next one. This is our long problem, which I'm sure some of us have questions about, so I'm going to do it here. This is the long one. This is the challenging mama of the problems. Okay, so you've got two radicals and this side is not 0, so that's what makes it long. Okay, so first, isolate one of the radicals. So I'm going to move the square root of x minus 2 to the other side to start. So that gives me square root of 2x plus 5 equals 3 plus the square root of x minus 2. Okay, just move that over. Okay, now I'm going to get rid of this radical on the left by squaring both sides. Okay, so that's just 2x plus 5. That's what we wanted. Get rid of that radical. But on the right-hand side, it gets messy because now you have to FOIL that. That's 3 plus the square root of x minus 2 times 3 plus the square root of x minus 2. If it helps, you can just write it out. 3 plus the square root of x minus 2. And then the squared goes away. Now you have to FOIL that. So 3 times 3 is 9. Plus 3 square root of x minus 2. Plus 3 square root of x minus 2. Plus, and then the square root of x minus 2 squared. Multiplying it by itself, so just squared. Okay, now we can really simplify that right-hand side, so let's do that. First of all, we can combine like terms in the middle, so that's plus 6 square root of x minus 2. And then the square root of x minus 2 squared, we know that square roots and squares cancel, so that's x minus 2. Okay, now I'm going to move, let me get another color out. I'm going to move all three of those to the other side of the equation, starting to isolate the other square root. So I've got 9 minus 2, which is 7, so I'm going to subtract the 7. Whoops. Subtract the 7 on both sides. Just subtracting the 9 and adding the 2. And I'm going to subtract x. So that gives me x minus 2 equals 6 square root of x minus 2. Now divide by 6. Okay, so we isolated the other square root now. So now what you need to do is square both sides to get rid of the second square root. So you'll square the top and the bottom, which means again that you need to FOIL the x minus 2. If you FOIL that, x minus 2 times x minus 2, you should get x squared minus 4x plus 4 over 36. The square root and the square cancel on the right-hand side. And now we want to solve for x. So I could divide everything by 36 on the left-hand side, but the easier option is to just multiply 36 to cancel that out. So multiply this side by 36. Okay, so that gives me x squared minus 4x plus 4. 36 is gone, and I distribute it on the other side. So 36x minus 72. All right, now it looks a lot nicer, and we can solve this quadratic. So I'm going to move everything to the left-hand side. So two numbers that add to negative 40 and multiply to 76. Hey, how about this? We have these answer choices here, and so maybe, just maybe, we could use those to our advantage to figure out the two numbers. Did 3 and 8 multiply to 76? No. No. Oh, so look at the 2 and 38. 238. 2 times 38 is 76. And negative 2 plus negative 38 is negative 40. So this factors into x minus 2, x minus 38. Perfect. So our two solutions are x equals 2 and x equals 38. But wait, there's more. We do need to check those two solutions because this is a radical equation. So let's plug those back in really quickly just to check. If I plug the 2 back in, we've got 4 plus 5 is 7. Square root of 7 minus, what did I just do? Oh, sorry, 4 plus 5, what did I just say? 4 plus 5 is 9. Square root of 9 is 3. 2 minus 2 is 0. Square root of 0 is 0. And 3 minus 0 does equal 3, so the 2 works. Now the 38, so you've got 38 times 2 plus 5, just plugging that back in. So you've got the square root of 81, which is 9. And then I've got minus 38 minus 2 is 36. The square root of 36 is 6. 9 minus 6 is 3. Okay, so both of those worked. Both of them are solutions. We've got 2 and 38. That is the hard problem. That is the long problem that you would have to be really quick at to make sure you have time for it on the test. All right. Number 21. I think I just put on here because, oh yes, the answer choices are written a little differently than what we expected. So just going to do this one really quickly. I guess I need to make room. Let me erase this. Okay. 5x to the 5 halves minus 25 equals 0. This is similar to the problem that we just did. No, not really. But you've got a rational exponent, which is the same thing as having a radical as part of your problem. You've got the square root involved. So first, isolate the part that has the exponent, and that's just the x, right? That does not apply to the 5. So add the 25 to the other side. And divide by 5. And now we need to raise both sides to the reciprocal. Oops. Okay, so x equals, and my denominator there is odd, so we don't need the plus or minus. But I can rewrite that as a radical. Remember, the denominator is the index, so 5th root of 5 squared. 5 squared is 25, so 5th root of 25. So they just wrote the answer in radical form, and then they went ahead and squared the 5. So that's what maybe tricked us up on that one. Okay, number 23. I put this one on here because I think the answer choice was wrong. Let's check. So n to the 4/5 equals 3. I'm going to raise both sides to the 5 over 4 to cancel out that exponent. Okay, because this is even, I need plus or minus. Plus or minus. So that gives me plus or minus 3 to the 5/4. Which should be the last one. I think for some reason the one without plus or minus was showing up, but plus or minus anytime you take an even root, which is when your denominator here is even. All right, let's see. Next page. Okay, I'm gonna do this absolute value equation also because the answer choice is wrong. I have no idea how that happened. I could have been trying to fix the font and accidentally changed the answer. I'm not sure, but that's why I want to go over this one. I did fix it, so you should see it corrected here, but when you finish the review, it probably wasn't saved yet. Like the edit, once you've started the review, my edits that I make while you're doing it don't take effect yet. So anyways, I just wanted to go over it for that reason. So 12x minus 6 minus 15 equals negative 15. So first, isolate the absolute value. Adding 15 gives me 0. Okay, so I can't split this up into 2 equations because you can't make 0 positive and negative. Normally we would split this up into 2 and it would be make this number negative and keep it positive for the other. But this one we just have one option just to keep it positive. Okay, so we now solve for x. 12x equals 6. X equals 6 over 12, which is 1/2. So it should just be 1/2. I don't really know what it's counting as correct on here. But as you can see, 1/2 is the only correct answer. Okay, sorry about that mistake. Not sure how it happened. Human error. Next page. Okay, I believe this is the last one that I'm going to go over with you. Okay, so another absolute value problem. First, isolate the absolute value. So I've got 3 minus this absolute value of 3w plus 9 equals 6. So first, subtract that positive 3. And then I need to divide by -1 to cancel that out. Okay, so now I have absolute value, which is always a positive number. Absolute value is the distance a number is from 0, which is always going to be positive. Always positive. So that's a positive number. And then they're saying it equals a negative number, -3. That is not possible. Anytime you isolate your absolute value and it equals a negative number, you can say no solution, because that's not possible. So you can just stop right there. And this one right here with the empty bracket, that's another way of saying no solution, or the empty set. Okay, so no solution, empty set, all of that would be the correct answer when you have absolute value equal to a negative number. All right, I hope this helped answer any questions, clarify anything that you had questions about. If you have any other questions, feel free to send it to me on Remind today. I want all of you to do well on this test tomorrow so we can start this 9 weeks out strong. All right, have a wonderful day.